P.7 Equations. So we're going to start with simple linear equations and make our way through to some quadratics and some radical equations. So again, all of this should be reviewed from algebra and algebra 2, but maybe we take it a little step further, maybe we do it a little bit different. One thing we are going to do is we're going to work on leaving our answers in set notation. So that's definitely something that maybe we haven't done before. And remember, what that means is all your answers, whatever they are going to be in your set notation, okay? Whether there's 1, 2, 3, or 4 answers and such. So we're putting them in the set notation. Just a reminder, if there's no answer, that's when we're going to give the null set, the empty set. So that is something maybe a little bit new that we haven't done before as far as when we solve these. But as far as the solving process, it stays the same as you've done before. So if we run through a linear equation, remember a linear equation makes a line on a graph, which means it crosses the x-axis exactly once. So we should have one answer on all of these, okay? It's degree 1, which means we have one answer. So we can simplify the expression, get all our variables to one side, and isolate it. And once it's totally isolated and everything's simplified, that's where our answers are, okay? In general, we can have basically rational answers. We could have irrational, to be honest. No, we won't have irrational here. Only rational answers. We could have fractions. In general terms, I would say lowest terms, improper is fine. So just some general rules for leaving our answer here. So let's start with number 1. I see a lot of parentheses in there, so let's do some distributing to get rid of that, and we'll go from there. So I'm going to distribute on both sides here. So 2 times x gives me 2x. 2 times -1 is -2. We still have a plus 3 on that side. On the right side, I have x. -3 times x is -3x. -3 times 1 is -3. Let's clean up sides first before we start joining. So on the left side, I get 2x plus 1. On the right side, I get -2x minus 3. Now I'm going to join like terms, so I'm going to add my 2x to the other side. I end up with 4x plus 1, and that'll equal -3. Subtracting 1, I'm going to get 4x equals -4. Divide by 4, and x equals -1. Now, to be honest, on a linear equation, if you can solve for it and you did your math correctly, there's about no way that that answer doesn't work. You can always plug it back in and check it, but there's really no red flags on a linear equation that we have to be careful of. So on number 2 here, I see that I have a denominator under this. I'm going to be honest, when there is an equal sign involved, the best way to get rid of denominators is to multiply by your least common denominator, okay? But make sure there is an equal sign involved. Otherwise, it's an expression and you can't do that, okay? So I see an equal sign here. I have 5, 2, and 3. And if I look at those, they're all prime numbers. I multiply them together. It looks like a 30 as a lowest common denominator would be great. Instead of changing everything to 30, I am going to simply multiply every expression by 30. I'm going to multiply by that common denominator, okay? So what's nice is when I do 3x over 5 times 30, my 5 and my 30 can reduce to 6 and I get 18x, okay? And you may do this mentally. I want to show it though. Negative times x minus 3 over 2 times 30. My 2 and my 30 can reduce to 15. And now I'm really distributing a 15 into this. I'm going to write it -15 and x minus 3 to catch that negative with the 15. And finally, I see my equal sign, and I see x plus 2 over 3. When I multiply that times 30, the 3 and the 30 reduce to 10, and I'm really doing like 10 times x plus 2. I have no more fractions because I took them times this common denominator, which helps simplify them all down. So now I just have a linear equation. 18x, I'm going to distribute my -15, get -15x plus 45, and distribute my 10, and I get 10x plus 20. Cleaning up the left side, I get 3x plus 45 equals 10x plus 20. Joining x's to the same side, I'm going to bring them to the right since there's more on the right side. So I get 45 equals 7x plus 20. Subtract 20, I get 25 equals 7x. And we can already see this isn't going to be a pretty answer, but it's still fine. I get x equals 25 divided by 7. That's in simplest terms. I'm good with it. I'm going to put my set notation around it and call it good. Okay. one answer for linear equations, work to get the variable by itself. Let's move on to rational equations. Okay, we just did a section, took a couple days on it to talk about simplifying rational expressions. It's still a fraction. I can't stress enough, the best way to do it is to get some common denominators, and then we're going to use the strategy we just saw in our last problem to get rid of our denominators, okay? So first I look at number 3. I have 3 terms, 8x over x plus 1 equals 4 over, I'm going to put that invisible 1, minus 8 over x plus 1. So as far as common denominators go, it'd be nice if we used x plus 1 on everything. So I'm going to have 8x over x plus 1. Because I'm turning my 1 on the bottom to x plus 1, I'm basically multiplying by that x plus 1. So my 4 is going to be multiplied by x plus 1 when I get the common denominator, minus 8 over x plus 1. Okay. Now, because everything there has an x plus 1 in the denominator, I am allowed to multiply by that denominator of x plus 1. One thing I do want to stress before I go much further, though, is as soon as you work with a rational expression, when you have variables in the denominator, you do need to be careful that you have values in your domain that are not allowed as a solution. So when I look at this one, I cannot have, remember, my denominator cannot equal 0. It cannot equal 0, so that means x cannot equal negative 1. So keep that in mind as we solve this, that x will not be allowed to equal negative 1. All right, so I multiply everything here by x plus 1. Well, I'm going to kind of overshow this on this one, but as we get into the rest of them, you're going to see what happens, and I probably won't show the work every time. I'm going to multiply this one by x plus 1. By the way, this is 4x plus 4. I'm going to distribute that while I can. I'm going to multiply the at by x plus 1. And then negative 8 over x plus 1, I'm going to multiply by x plus 1. When I multiply by this denominator, these two cancel. I'm left with 8x. These two cancel. I'm left with 4x plus 4. These two cancel. I'm left with minus 8. So when you multiply by a common denominator, it wipes out the denominator, and it's gone forever. We don't have to worry about it, okay? We kept the value of our equation the same, but we got rid of that denominator, so we're done with it. So now I'm just going to clean up. On my right side, I get 4x minus 4. I'm going to subtract the 4x and divide by 4, and I get x equals negative 1. Now, my original equation had x plus 1 in the denominator. If I plug in negative 1 there, I'm going to end up with 0 in the denominator. We may never divide by a 0. That is not allowed. And we already made that statement up here that x cannot equal negative 1. So because of that, the answer here is going to be the null set. I do not get a solution to this equation. All right, second one for number 4 here. Again, I see some denominators, x plus 1, x minus 1. I get x squared minus 1. I can rethink of that as x plus 1 times x minus 1. Okay. Now, it looks like the best thing to do is to multiply by the common denominator. Okay, and just for a side note, what can x not equal on this equation? It looks like I can't make it equal negative 1, and I can't make it equal 1. So let's keep that in mind as we try to solve if that comes up as one of our solutions. Okay, so I am going to use the common denominator of x plus 1 times x minus 1. The nice thing is on the right side, that 2x is going nowhere because it already had that denominator. All right, on my first one, I had 2 over x plus 1, but now that I put an x minus 1 in the denominator, I need an x minus 1 in the numerator. On my second fraction, I had an x minus 1, but I joined an x plus 1, so that 1 on top needs to also have an x plus 1, because when we change the denominators, we need to change the numerators with the same factor. Okay. At this point, everything has the same denominator. I'm going to go ahead and multiply by that denominator, and I'm not going to show the work this time. This is going to cancel all of this. So on the left side, I have 2 times x minus 1 minus 1 times x plus 1 equals 2x. Much easier equation now to solve for. Distributing 2x minus 2, distribute the negative through this, negative x minus 1 equals 2x. Cleaning up the left side, I get x minus 3. Subtract an x, and it looks like I'm there. Is x allowed to equal negative 3? Yes, my only restrictions were -1 and 1. And if I plug it back into that equation, I should get a true statement up there. So I'm going to go with my set notation of -3. And guys, after years of making these little set notations, I'm still not that great at them. So it's okay. As long as I can tell it's not a parenthesis, squiggle away. All right, so we've done okay with linear. We pulled in those rational. Let's work on solving for a variable. Okay, the key to solving for a variable, use your algebra rules to get that variable by itself. That's all. Remember, you simplify what you can, but in reality, when you solve for a variable, there's not much to simplify for. Okay, so you basically just move things around so it looks prettier than it did. So my first equation, I don't know if anybody remembers what this equation's for. A equals 1/2 h times b1 plus b2. Yes, that is the area equation for a trapezoid. We're going to try to isolate b2 and get it by itself. So, one thing at a time. Right now I have a 1/2 on the b2 side. I don't like it there. I'd like to get it to the other side. How do I move 1/2? Multiply by 2 on both sides. So I get 2a equals h times b1 plus b2. Multiple things we can do now to get rid of the h. Remember, always get rid of things as far away from the variable as possible first, and then slowly move in until you get closer to the variable and get rid of those items. Right now, this h is being multiplied times the parenthesis. We have two choices. We can distribute right now, or I can just divide both sides by h to get rid of that multiplying by h. Cancels on this side. On this side, I'm left with 2a over h equals b1 plus b2. One final step to go. I want b2 by itself. It's connected to b1 right now. I can subtract by base 1 and get there. Now, the one key thing to realize is that b1 is subtracting by that chunk that's over there. So I need to make sure 2a over h is by itself, and then I'm going to subtract that whole chunk by b1. Do not put b1 or base 1 on top with the 2 times a. It does not go there. It is separate from that fraction. And b2 is by itself. Our job is done. There's really no simplifying I can do there. Okay, so now going to number 6 here. Number 6 has some new challenges. I'm solving for f2. And just kind of a reference sake, when you look here, I see 2 f2s. We can't solve for f2 until there's one f2. So we've got some multiple steps to get there, okay? First things first, never, ever, ever can you solve for a variable when it's in the denominator. So if you have your variable you're looking for and it's in the denominator, get it out, okay? How do I get f1 plus f2 out of the denominator? Well, I can multiply both sides by f1 plus f2, okay? And I'm afraid on some of these is where we're going to find that my sloppy writing with a stylus is going to possibly cause us some confusion. So hopefully we can follow this. On the left side, I'm just going to do f times f1 plus f2. On the right side now, at least my denominator's gone and I just have f1, f2. Okay. So on the left side, let's distribute this f, and I get f, f1 plus f, f2. And right now it equals f1, f2. We are trying to solve for f2. There are 2 of them. Currently they're not on the same side. Let's put them on the same side. So f1 equals f1, f2 minus f2 that came from the other side. Okay. We now have our f2s on the same side, but there's still 2 of them. How can I go from 2 of them on terms that are not like terms, I'm not allowed to combine them, and get down to 1 f1, or f2, that's what I'm going for. And one of our favorite things to do, factor, right? DCF factoring on that one. 2 of them, so I pull out the f2, and I'm left with f1 minus f. And now I finally have my equation down to 1 f2, which is important because I can only use one of that variable when I solve for that variable. What's still connected to f2? That multiplication, that whole chunk. So how do I get rid of it? I divide by it, okay? So I'm going to divide both sides by f1 minus f. And I can't stress enough, rarely will you ever be able to simplify anything. On this side, you definitely can't. So my final answer here is f2 equals f1, that's a multiplication on top, divided by f1 minus f on the bottom. And remember that rule that if things are being added or subtracted, they cannot reduce with things being multiplied. So we are done right there. That is our answer, okay? All right, so we've done linear, we've done, yes, that one. We've done linear, we've done rational, we've looked at solving for a variable. Now let's look at an absolute value equation, okay? Ugh. Okay. I'm going to get this someday. Okay. Absolute value equations. Super, super important to realize there can be two answers to these, okay? Because absolute value can have different options, okay? So, quick reminder, and this is so important when you do this, you must get your absolute value by itself on one side first. You have to, okay? So, always, always, always get the absolute value by itself first, okay? If it's not by itself first, you cannot do anything. So work to get that absolute value as the only thing on one side of your equation before anything else happens, okay? The other thing to always check for is if you end up with a true statement, okay? So I'll kind of walk you through one of them. We'll catch on each of these. Number 7, I have 2 times the absolute value of 3x minus 2 equals 14. So I have to get my absolute value by itself first, so I'm going to divide both sides by 2. I get the absolute value of 3x minus 2 equals 7. Okay, is that a true statement? Can my absolute value equal positive 7? Definitely. So now because we know that, what we have in the middle has the chance this 3x minus 2 can either equal 7, and then its absolute value is 7, or that statement in the inside there can equal negative 7 because it, once we take the absolute value of it, it'll still equal 7. So we do a split with absolute value equations because the value inside can be either positive or negative. We do the split, it gives us two equations, we solve them separately. 3x equals 9 on the left, x equals 3. We plug into the, we solve on the other side, we add our 2, 3x equals negative 5, and we divide in x equals negative 5 over 3. Okay, remember, just because our variable is negative does not mean it's gone because of the absolute value. It's when we plug it back in, okay? If I plug in 3, I get 3 times 3 is 9 minus 2 is 7. Is the absolute value of that 7? Yes. If I plug in x equals negative 5 over 3, negative 5 over 3 times 3 is negative 5, minus 2 is negative 7, and is the absolute value of negative 7 7? Yes. So we get either answer. So in my set notation, I want to put both of my answers. In this occasion, it is not an absolute that you need them in order from lowest to highest. We are going to have a time where they have to be lowest to highest by the time we end this chapter. So it's not a bad habit to get into right now. I won't mark it wrong if you say the answer is 3 and negative 5/3. But if you can get in the habit now of putting your lowest first and your next in order next, it will just help you transition later into that new rule as we get to it. All right, second equation for my absolute values here. I have the absolute value of x plus 1 plus 6 equals 2. Always, always, always get your absolute value by itself first. So I subtract 6. The absolute value of x plus 1 is equal to negative 4. Is this a true statement where an absolute value is equal to negative 4? No. We can never do it. There's no need to solve this. You can do the algebra, but your answer will always be false anyway. So I'm not even going to bother. This is going to be the empty set because we cannot find any value that its absolute value will be negative 4. Okay? All right, so note on the bottom here will lead us into our examples on the next one, but I decided with space on here, I'd put this down here at the bottom. We're going to move next for quadratic equations. Okay, remember a quadratic equation has a degree of 2, right? There, anything with x squared is the highest degree and it goes down. So degree of 2 here. A second degree polynomial, that means we should get 2 solutions every time we solve these, okay? Now, occasionally, those 2 solutions are the exact same number. That's okay. But we should be able to come up with 2 solutions or tell why we know both of the solutions are the same number. So keep that in mind every time that I need 2 solutions to a quadratic equation. All right, so this page here, All of these are quadratic. We have different options on how we can solve quadratic, and I'm going to walk you through different ones. Now, for the most part, you get the choice how you want to solve your quadratic. You can choose whatever way you want. But the important thing is that your method is successful. There are times when certain methods will not get you an answer. So make sure you choose a method that will definitely get you the answer. So the first one I put on top was by factoring, because I'm going to be honest, as much as you wanted to deny this in Algebra 1, you might agree with me finally. Factoring is the fastest if it works, right? If you can think about it, if you can factor, these things go fast, okay? But it's not always feasible. Okay, first things first though, this is a must. You need to make sure it's set equal to 0. If it's not set equal to 0, factoring is worthless, okay? And remember, the reason is I want things multiplied together to equal 0, because then I know one has to be 0. If you multiply things together and they equal -7, who knows what those two numbers could be, okay? But if you multiply things together and they equal 0, you know one of them has to be 0. So it's so important to make sure your equation is set equal to 0 before you solve. All right, so first one first, it's not set equal to 0. I personally always want my x squared to be positive, so I'm going to move everything to the left, call it x squared minus 13x plus 36. Now it equals 0, and I'm trying to see it, if I can factor. This is an easy factoring, so I'm not going to go my full out method where I separate. Do you know any factors of 36 that add to make 13? I believe 9 and 4 will work to add to make 13. And it looks like both will need a negative sign. Okay, so recall, if I have an expression or a factor times a factor and it equals 0, one of those has to equal 0. So x minus 9 equals 0, or x minus 4 equals 0, which means when I add 9 over here, x equals 9, or x equals 4. Because this is a quadratic, I look at it, I can plug in 9, I'd get 81 minus 13 times 9 plus 36. That would come out to 0. It works. I plug in 4, 16 minus 13 times 4 plus 36. That also works. So it looks like I am good with my answers in my set notation of 4 and 9. Okay. Second one in my factoring examples, 5x squared equals 20x. Again, try to get it equal to 0 first. I like 5x squared minus 20x equals 0. Back to our factoring rules from the other day. Only two terms. Anytime, any factoring, if there's a GCF, go for it. Looks like I can pull out 5x, which leaves me with x minus 4. That does not factor anymore, but because I have two factors multiplied times each other, either 5x equals 0 or x minus 4 equals 0. So I divide the first side by 5 and x equals 0. I add 4 to the other side on the second one and x equals 4. I plug them back in. Obviously 0, 5 times 0 equals 20 times 0. That works. Plug in the 4. 4 squared is 16 times 5 is 80, and so is 20 times 4 is also 80. So both of them work. I put both in my set notation, and I'm good. Okay, factoring, when it works, is the easiest way to solve a quadratic formula, in my opinion. Maybe you feel differently, but it's a method. Okay, so let's move to the next method, which we have, which is the square root property, okay, which says take the square root of both sides. The time this is the most successful is if there is no x term, okay? And I say x because that's our most popular variable, but basically if there's no singular with a degree of 1 term, that's when this is the most successful. So I get 3x squared minus 1 equals 48. I don't see an x term. I'm going to go for the square root method, which says get your x squared by itself, okay? So I'm going to add 1 to the other side. I get 3x squared equals 48. Divide by 3. I get x squared equals 16. I need to solve now because I have an x squared. I can take the square root of both sides. And what is the square root of 16? This has taken us back to that special rule. A square root has two square roots, right? It's either positive 4 or negative 4. Those are distinctly two different answers, negative 4 and 4. which makes sense because I need two answers to my quadratic here. Okay. I told you we couldn't totally forget that rule, right? So we do have to remember that. All right, next one. Not quite exactly like we see on the other one. Sometimes we are tempted on a problem like this to take that x minus 4 squared and FOIL it out. And I'm not telling you that's wrong. You can do it. It works. Go ahead and do it if you want. Distribute that 3 in if you want. That's a perfectly acceptable way to do it, okay? But as a shortcut method here, because that's already in a nice squared term, I'm going to work to get it by itself. So I'm going to divide both sides by 3 and get x minus 4 squared equals 5. And now because I have this perfect square on one side, I'm going to take the square root of both sides, okay? My square root and my square will cancel, and I'm left with the expression x minus 4. And don't forget on the right side, I get plus or minus the square root of 5. It doesn't come out to a whole number. I'm going to leave it exact, so I'm going to leave it as the radical and work to get x by itself. Now to get x by itself, I'm going to add both sides with 4, or add 4 to both sides. And I can leave this in the standard form how we like to see this best. It would be a positive 4 plus or minus the square root of 5. That is technically two different answers, okay? You can write them separately in your set notation. I'm okay with you writing it just 4 and plus or minus the square root of 5. That is acceptable, okay? All right, moving on. If I can. The hardest thing on my iPad when I do this is moving the pages up and down. So, and I do want to apologize for any noise you hear now. Tried to lock myself in the bedroom. The dog knows how to open the door, just came in, decided to lay in his cage where he's noisy. So I apologize now for any odd dog noises. All right, 13 and 14. Solve the quadratic equation by completing the square. If you are like any normal algebra students, you will avoid this method with all costs. But I'm going to tell you right now, there's no way you're going to get through pre-calculus without being able to proficiently complete the square. So the best thing to do is just get over your fear of it, get over your avoidance of it, and just make sure you get better at it this year, because we're going to complete the square in a lot of processes, so make sure you're familiar with it. Okay, so just kind of to step you through a few of these. Hopefully I can write this somewhat legibly. Okay, the first thing we're always going to do when we can complete the square is divide by coefficient of x squared. Coefficient of x squared, okay? If there is one. That's the first step you want to do, okay? Step 2, we're going to get x's on one side, constants on the other. Remember, these are equations we're working with right now, so this process would alter slightly if we were working with just an expression, which we will do later on. So just kind of know that this is specific to the equation. And then we're going to do the b divided by 2 squared. And as we go through this example, this will make more. I'm just kind of writing down the steps for you here. And we're going to add that to both sides. And finally, we're going to be able to complete the square and solve. Okay, so let's practice it with this first one. I'm going to change colors so I don't run into my notes here. X squared minus 6x minus 11. First step says divide by the coefficient of x squared. Well, currently my invisible coefficient is 1, so there's really nothing I need to do there. So I'm ready to go to step 2. I want x's on one side and the constant on the other. So I'm going to leave my x squared minus 6x. Sorry about this. X squared minus 6x on the left, and I'm going to add 11 to the other side, okay? You'll notice I left a little bit of a gap. Okay, so on step 3, I take my b term. If you remember on the quadratic equation, a is the coefficient in front of the x squared, b is the coefficient in front of the x. And I'm going to be honest, then positive or negative is never going to matter in this case, so you don't need to worry about it. So I'm going to take the b, which is 6, I'm going to divide by 2, and I'm going to square it. Well, 6 divided by 2 is 3, squared is 9. This is the number that I'm going to add to both sides. I'm going to add a plus 9 here, and I'm going to add a plus 9 here. As long as I do the same thing to both sides of the equation, I've kept an equivalent equation. I haven't changed its value in any way. Okay, what's nice on the left side is I have a trinomial, x squared minus 3x plus 9. And if I go to factor that, I get an x minus 3 and an x minus 3. On the right side, I get 20. This on the left now is what is the completed square. It's x minus 3 squared. What we did was give a number to make that a perfect square. That's how we completed the square. Now it looks like number 12, and we can solve it with the square root method. So I can take the square root of both sides. I get x minus 3 equals plus or minus the square root of 20. If we can do this in our head, 20 is 4 times 5, so how about 2 square root of 5 to keep it in simplest terms. And now I want x by itself, so I'm going to add 3 to both sides, and I get 3 plus or minus 2 square root of 5. So those are my two solutions, because 3 plus 2 square root of 5 and 3 minus 2 square root of 5 are my two solutions. So I get 3 plus or minus 2 square root of 5 for my two solutions here. All right. Try it again. A little bit different on this one. I have 2x squared plus 8x plus 2. My first rule says divide by the coefficient of x squared if there is one, and in this case there is 2. So that means everything here gets divided by 2. That leaves me with x squared plus 4x plus 1. Step 2 says get your x's to one side and your constant to the other. That'll make that negative 1 when we move it across the equal sign. I'm going to take my middle term of 4 and divide by 2. And square it. 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 to both sides. Kind of running out of room over here. That factors to an x plus 2 and an x plus 2. And this simplifies to 3. That gives me an x plus 2 squared. That's my completed square, equals 3. And now I'm ready to take the square root of both sides. I get an x plus 2 equals the plus or minus square root of 3, and subtract 2, and I get negative 2 plus or minus the square root of 3, and there's my two answers. So, completing the square. I do want to give you the heads up at times when you do a divide by 2 and square it. Sometimes if you have an odd number there, I gave you nice ones 6 and I gave you 4. They do come out to whole numbers. You can end up with obviously odd numbers there, and they don't look so pretty. Personally, I like to leave them as fractions, because if it was 3 over 2, I'd make it 3 over 2. When I squared, I'd make it 9 over 4. You do have to add that to both sides. So just be careful. Not all numbers come out super pretty, but the process is the same for all of them. Okay, so we solved by factoring, we solved by square root, we solved by completing the square. Now we're going to do the quadratic formula. I do want to throw out there, though, there are technically 5 ways to solve a quadratic. I'm not going to do the 5th way. The 5th way is by graphing to see where it crosses the x-axis. That means you get to draw that beautiful parabola, whether upside down or right side up, whatever you want to call it, and check to find the exact value on the graph where it crosses the x-axis. Needless to say, negative 2 plus or minus the square root of 3 is not a pretty number to try to figure out on a graph. Graphing is a way. It's not always a super accurate way without the use of technology with a graphing calculator or such. So throwing it out there, it's a way, but we're not going to focus on that one. Okay, the last way we are going to do is the quadratic formula, where we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Am I going to ever give you that formula? Absolutely not. You are perfectly capable of memorizing that if you don't have it memorized already. Okay? Quadratic formula is never going away, and the quadratic formula is the one and only way that will solve absolutely every quadratic equation. Okay? You heard that right. It is foolproof. It will solve absolutely every quadratic equation. Are there more steps? Is it more tedious? Is there room for mistakes? Most definitely. So typically, if we can factor like we did on the top one, we probably would factor first. But I will tell you, quadratic equation is foolproof and can be used on every equation. Okay, so the key thing to remember when we do the quadratic equation is to make sure we understand we need to be in standard form equal to 0. So make sure you're set equal to 0. If you're not set equal to 0, you're going to be in trouble on these. So make sure you set equal to 0. This first one is good. It's in standard form. It's set equal to 0. Remember, the coefficient in front of the x squared is your a. So in this case, my invisible a is 1. The coefficient including the sign, okay, in front of the x term is your b, so it's positive 8. And the constant is going to be your c, and again, including the sign, in this case, it's positive 12. And we are going to plug and chug through our formula. So the first thing is the opposite of b is sometimes how you hear it say it, negative b, so I have negative 8 plus or minus. By the way, that plus and minus is so important because it will give us our 2 answers. And now we're ready for inside. B squared, so 8 squared minus 4 times my a of 1 times my c of 12 divided by 2 times my a of 1. I get negative 8 plus or minus. I prefer to take my quadratic formula in chunks, 3 chunks. My first chunk is 8 squared. I make it 64. As silly as this sounds, my next chunk is the minus. I simply write it no matter what every time. And then I like to chunk the last 3 numbers together. These are all positive right now. 4 times 1 times 12 is 48. And I divide by the 2. Okay, and just a quick note. This division is the entire thing. It's not just the number outside. It's not just the number under the radical. It's the whole thing. Okay, so keep that in mind. All right, inside I still need to simplify. Negative 8 plus or minus the square root of 64 minus 48 is 16. That's actually lots prettier than we usually get. All right, I can actually take the square root of 16. I often can't. And I'm going to get negative 8 plus or minus 4, since I can actually take the square root divided by 2. Okay, so here are my 2 answer choices. Negative 8 plus 4 divided by 2, and negative 8 minus 4 divided by 2. Well, negative 8 plus 4 is negative 4 divided by 2 is going to be negative 2. So there's one of my answers. Negative 8 minus 4 is negative 12 divided by 2 is negative 6. There's my second answer. So negative 2 and negative 6, of course if I write them in order, negative 6 is smaller. Those are my 2 solutions here. I'm going to be honest, that one would have been really fast to factor, right? But the quadratic formula works for it. All right, last one on this page, and I am running out of blank space. Let's hope I can squeeze this in here. Okay, first things first, set it equal to 0. 3x squared minus 6x plus 1, as I move those over, equals 0. If we do not move those all to the same side, we will have sign errors, and it will be guaranteed to pretty much give you a wrong answer. So please, please, please set it equal to 0. Okay, a is definitely 3, b is definitely negative 6, and c is definitely 1, okay? Opposite of b, so I'm going to get 6 plus or minus the square root of b squared, so negative 6 squared, minus 4 times my a of 3 times my c of 1, all over 2 times a, which is 3. So I'm going to get 6 plus or minus the square root of negative 6 squared is 36, minus 4 times 3 times 1 is 12, all over 2 times 3, which is 6. I get 6 plus or minus 36 minus 12 is 24 over 6. All right, not as pretty as the last one. It doesn't come out whole. 24 can reduce to 4 times 6, so 2 square root of 6. So I get 6 plus or minus 2 square root of 6 over 6. Is this my simplified answer? Well, this is what I want to stress to you. You can have to check all 3 of these numbers right here. If all 3 of those can be reduced by the same thing, you can reduce them. If they can't all 3 be reduced by the same thing, I personally wouldn't touch them. Okay? So, because all of them can be divided by 2, I'm going to make this 3 plus or minus. The 1 is optional if you want to write it there or not. Radical 6 over 3. And that is going to be my set notation there for my 2 answers. 3 plus the square root of 6 over 3, or 3 minus the square root of 6 over 3. Obviously decimal answers there because the square root of 6 is not perfect, but that's my most exact answer there with the quadratic formula. So for the 5-way methods, we can solve a quadratic by. You choose which one you like best. Remember, the one that works on everything is the quadratic formula. You must have it memorized, though. I won't be giving that to you. All right, last page. Kind of coming in to talk about some of these little detail ones, okay? So if you look at a quadratic and you say, well, wait, can all quadratics be solved? Yes and no. So we have 3 different options. We can have 2 solutions. We can technically have 1 solution that is actually used twice. And we can have no real solutions, okay? Just a quick heads up. Think about your quadratics, okay? A quadratic's a parabola. So you have your axes. You can have a parabola that's really nice and it crosses the axis twice, okay? That means 2 real solutions. You can have a parabola that touches the axes exactly once, okay? That x-axis just once. That one is the case where it has 1 solution that is technically the answer twice, okay? Then you still have your parabola, right, that you draw there, and when you're done drawing the parabola, it never touches the x-axis, okay? If it never touches the x-axis, it has no real solutions, okay? Those are our 3 options if you want to think of them visually. So how can we quickly tell if an equation does or doesn't have solutions? So we use what's called the discriminant, okay? And that's a quick check. And if you think about your quadratic formula, which was which was negative b plus or minus the square root of b squared minus 4ac all over 2a, this b squared minus 4ac is the deciding factor because it's a square root. If I get a negative under that square root, I can't take the square root. That means there's no real solutions. So if that b squared minus 4ac is negative or less than 0, we're getting no real solutions. My graph looks like this. If that b squared minus 4ac happens to be a perfect square root or positive, right? Anything positive, a perfect square root, you're going to have 2 real solutions, okay? And you have a graph that looks like this. If this b squared minus 4ac equals exactly 0, okay, so there's no plus or minus to do because there's no number behind it, it means you get 1 solution, okay? And your graph looks like this. So that value in there, when simplified, can tell us what kind of solution we have without doing the complete quadratic formula, okay? Once again, if you're going to try this, you have to make sure things are set equal to 0, okay? So please make sure you set equal to 0 first before you try anything. Okay, my first one, 17, it's set equal to 0. It's in standard form. I can go ahead and identify A as 2, B as positive 11, and C as negative 6. All I'm checking for right now is b squared minus 4ac. I'm not going to do the whole thing. So I get 11 squared minus 4 times a of 2 times the c of negative 6. 121 minus, and 4 times 2 is 8 times 6 is 48, and it's a negative 48. Well, I can tell already, and I'm going to be honest, the number itself doesn't matter. I just know my number is positive, okay? I think it's positive 169. That means I should be able to get 2 real solutions to this equation, okay? Checking number 18 here. Make sure it's set equal to 0 first. 4x squared minus 3x plus 5. Set it equal to 0. So A is going to be 4, B is going to be negative 3, C is going to be positive 5. So I'm just doing b squared, so negative 3 squared minus 4 times 4, which is my A, times my C, which is 5. So negative 3 squared is 9 minus 4 times 4 times 5. Actually, I'm going to do 5 times 4 is 20 times 4 is 80. I'm definitely getting a negative number, to be honest. The number itself doesn't matter. The negative does. It would be 71, though. And because of that, I have no real solutions. Okay? So just remember that you could get no real solutions, in which in case you would call it the empty set if you were actually trying to solve that, okay? All right, last and final method we need to go over is solving radical equations, okay? And you can do a radical equation whether it is the square root, the third root, the fourth root, the fifth root, whatever, all of those are possible, okay? What you need to do is, as much as possible, you want to range your equation so one radical is isolated on one side of the equation. So get your radical by itself, okay? Then you're going to raise both sides of the equation to that power, okay? And it should eliminate that root. And then you solve the resulting equations, okay? This is one of the first times, remember, when we did rational expressions and we had denominators with variables in the denominators, there was a chance of your answer not working. Because if you recall, numbers or variables in your denominator are ones you have to be careful of. That's a red flag. You can't make that let that equal 0. Because we have radicals or square roots, once again, we have to be careful and we need to make sure we check all of our solutions because we may not be able to have something equal a negative inside our radicals. So this is, again, one of those times we better double check our answers at the end. All right, so let's try number 19. I have a square root of 20 minus 8x equals x. My radical is already isolated on one side, so I am ready to right away just square both sides, okay? When I square a square root, they cancel, and I get 20 minus 8x, and x squared is just x squared. Looks like I have a quadratic. I'm going to set it equal to 0. X squared's on the right, so I'm going to move the other two things over, make it plus 8x and minus 20, so that I'm in standard form. My choice now, quadratic formula, completing the square, square root, factor. I'm going to start with factoring because it's faster. Are there factors of 20 that subtract to make 8? Yes. 10 and 2, right? A plus 10, a minus 2. Okay. So that means either x minus 2 equals 0. Whoa. Okay. X minus 2 equals 0. Or x minus or plus 10 equals 0. So x equals 2 or x equals negative 10. Okay. We always do a double check before we put our answer in here. So if you think about it, the square root of 20 minus 8x. I plug in 2, 20 minus 16. I get the square root of 4. Does it equal 2? Yes, we're good, okay? And by the way, for the most part, we need to make sure our square roots equal a positive number, right? Okay, so we solve for negative 10. If I do square root of 20 minus 8 times negative 10, we get negative 8, get positive 80, so I get the square root of 100. Does that, and that is 10. Does that equal negative 10? It does, so we can answer, we can get an answer there of negative 10 and 2. Okay, so we're good on that one, okay? Let's try number 20 now. First things first, we want to get that square root, or as by itself as possible. So let's subtract x to the other side. So I get negative square root of x plus 11 equals 1 minus x. Divide by negative 1 on both sides to get rid of this negative on the outside. I get the square root of x plus 1 equals negative 1 plus x. Okay? If you want to write it x minus 1, that's fine. Now I'm going to square both sides to get rid of my square root. This cancels. I get x plus 11. By the way, this one on the right, that means I need to take x minus 1 times x minus 1, right? I'm taking that binomial and squaring it. So when I FOIL that out, I get an x squared minus a 2x in the middle plus 1 on the end. Okay? Set equal to 0. X squared, subtract an x, I get negative 3x. Subtract 11, get negative 10. Do we have factors of 10 that subtract to make 3? Negative 5 and 2. So x equals 5 or x equals negative 2. Okay. Plug and chug through to make sure this works. If I have 5 minus the square root of 5 plus 11, does it equal 1? So 5 plus 11 is 16. The square root of 16 is 4. Does 5 minus 4 equal 1? Checks, no problem. Plug in the negative 2. Negative 2 minus the square root of negative 2 plus 11. Okay, so negative 2 plus 11 is 9. So I get negative 2 minus the square root of 9, which is 3. Does that equal 1? No, it does not. That one does not check. So the only answer I want to use here is 5. Don't use that negative 2. Okay, so make sure you do a plug and chug to check for that. All right, there's my equation notes. Practice them, page 98 there, 3 through 132 by 3s, or do the odds so you can check the back of the book, check with Mr. Slater. Do the problems you need to practice. Make sure you are just capable of solving any and all of these type of equations. Please let me know if you have any questions.